Grade 12s, we're on our 8th day of exponential functions, and we're doing logarithms again, and I know that they're very intimidating, and they were a little bit yesterday, and we hope to get through some graphs of logarithms and not scare you too badly. We introduced logarithms as a way to solve exponential equations. So for instance, if you have 7 to the x equals 112, and we wanted to find the value of x, the only tool that we have had so far is to do a guess and check. 7 to the what would make sense to get 112, and we could come up with some reasonable guesses. So logarithms were introduced to rewrite that relationship between 7 and x and 112 in a different way. So log base 7 of 112 equals x is the same thing, just written in a different way. We can then use principles of logs to solve for x exactly using a calculator and not guess and check. So if I have log base 7 of 112, I can use a different base and do log base 10 is implied, divided by log base 10 of 7 on my calculator, and I will get an exact answer for x. Log of 112 divided by log of 7 is about 2.42. Let's see if that seems reasonable. 7 squared is 49, and 7 cubed is 343. So it makes sense to me that my answer should lie between 2 and 3, and I was able to use logs to solve it. This first example, evaluate log 16 divided by log 3. To my brain, I like to work off to the side and say, what does that mean about 3 and 16? It means that log base 3 of 16 is equal to x. And so 3 to the x is equal to 16. Those three things are all the same. I like to guess and check, at least in my head, and see if I come up with the right answer. 3 squared is 9. 3 cubed is 27. So I know my answer lies between 2 and 3. Let's use our calculators. Log of 16 divided by log 3. 2.52. 2.52. Okay, the next one, log 15 divided by log a third. So for me, I like to get an idea of what this means. If I am able to divide log 15 by log a third, that means log base a third of 15 is the x that I'm looking for, which, and I like exponents a lot better, 1/3 to the x is equal to 15. That's a tricky one, but I know if I have a fraction to a power and my exponent were negative, then I would have a flip. And I can't spell, but that's okay. So x is going to be a negative number. 3 to the something that gives me 15. Well, 3 squared is 9. 3 cubed is 27. So my prediction would be that my x value should be a negative between -2 and -3. Let's type it into our calculator. X is approximately -2.46. So there are some questions on page 78 that could give you some more practice with these and get more familiar with them. All right, let's look at graphing now. The graphs of exponential and logarithmic functions are opposites to each other. We introduced logs to be the opposite of a power. So just as an example over on the side, if 8 equals 2 to the x, then log base 2, same base, of 8 equals x. You know the answer is 3. Either way. And it's the same relationship. those relationships are opposite to each other. So our graphs should look like opposites. Y equals 2 to the x. We've seen this before with a table of values, so I won't write a table of values for you. I'll just graph it. For exponential functions, our y-intercept is 1. If I did a value of 1 in that equation, I have 2 to the 1. When x is 2, y is 4. When x is 3, it's 8, and it doubles as you go to the right. As we go to the left, when x is negative 1, I have a flip, a half, a quarter, and so on. And that has an asymptote that it approaches and never touches. Y equals 2 to the x. Okay, just knowing that powers and logs are opposite doesn't help us graph it. So let's just come up with a small table of values so that we can have a place to start. I'm going to strategically use some really pretty numbers. I'm going to use 1, 4, 8. And in a minute, I'm going to put a half. So if y equals log base 2 of these numbers, log base 2 of 1 equals, in other words, 2 to the what is 1? My answer would be 0. Log base 2 of 4 equals what? Well, 2 squared is 4. 3. For this one, log base 2 of 8 is 3. Here's a weird one. Log base 2 of a half is, well, I would need an exponent that would flip it to a fraction. So my answer would be negative 1. Let's put those values in and see the pattern. I'm going to leave the half to last. When x is 1, my y value is 0. When x is 4, 2, 3, 4, my y value is 2. When x is 8, my y value is 3. Okay, let's do that half now. When x is a half, y is negative 1. There. So I have a curve like that, which is the opposite to the exponential curve that we had before. I think it would be really good for you now to take a moment and do an investigation. We have 1.7.2 and 1.7.3, and I'll give you copies of those. And also graphs of logarithmic functions, number 4, for you to have a look at. Where we use logs most often to solve is when we are looking for time in an exponential equation. That's the hardest, other than guess and check, to solve. So let's try this one, and then I'll leave some problems for you to try as well. Suppose you invest $200 at 6% compounded annually. How many years would it take for your investment to grow to each amount? $300 and so on. So the equation is not so bad. If we want to deal with our money problems, we have an amount is from our initial amount times the rate of growth, which is 1.06 compounded annually to the power of n, number of years. I think those are the letters you would have used last year. We have an exponential function graph. I want to know how long it's going to take my $200 to become $300 at this rate. So I want to solve for the exponent, which is always the harder thing to do. So first thing I would do is divide both sides by 200. So I would end up with 3 over 2, or 1.5. 1.06 to the n. And now I want to know what my exponent is. Well, I could guess and check, but not very well, I can assure you. I know that this relationship can be modeled by, okay, if it's a log, I have the same base, 1.06, of 3 halves equals the exponent n. Well, I also know from the beginning that I can use my calculator with a different base, log of 3 halves divided by log of 1.06, and I can find my n value. If I type that in, 6.96. So approximately 7 years for that $200 to become $300. Let's try the $400 one. I want to know how long it will take my $200 to double. I can only model my own thought process, which is a little crazy at best, but I know that the relationship between these things is that 1.06 to the n equals, oh, I should have divided both sides by 200 first. Divide both sides by 200, and I want to know this equation. I know that 1.06 to the n equals 2, or I can write it as a log. Log base 1.06 of 2 equals n exponent. Well, from my solving, I can find n by log of 2 divided by log of 1.06, and I will get my n value. Log of 2 divided by log 1.06, 11.9 years, so almost 12 years. How long does it take my money to triple, really, at this rate? If I divide both sides by 200, it's a tripling. So n equals log of 3 divided by log of 1.06. Log 3 divided by log 1.06. 18.85, so almost 19 years. I'll give you some modeling sheet ones on page 75. We got lots to do.